Good morning and welcome to this webinar organized by Eurit and Power's Market Intelligence Unit. I'm Eloi and I will steer the discussions this morning. Today, we will present and discuss recent developments in France with a focus on renewable heat. Indeed, it's not very well known that there is a French way to reform the heat market. If we look back in time, the French heat market was dominated by oil in the 70s, a bit like everywhere in Europe. Then there was a strong wave of electrification with the nuclear program, and then natural gas expanded a lot. More recently, authorities have developed a toolkit of policy measures to grow sustainable heating and meet a target of 38% of renewable heat by 2030. And there is an obvious link with European developments and Repower EU, as recognized by the Commission in its Repower EU communication. In May 2022, district heating using renewable and waste heat is a strong option to help phase out imported fossil fuels. So how are things developing in France? Should you as investors go and develop green heat projects in France? What can we learn from the French way? These will be the topics for today. And the report prepared by Carbon 4 is very useful to understand the stakes, the state of play, and whether France is on track to meet its renewable target. So this report will be the basis for our conversation. We have 60 minutes. We will start now. Please, to participants, if you have questions, you can ask them in the Q&A section. We will take time for discussion. So I'm really happy this morning to be surrounded, as you can see on the screen, with great speakers. And we will start now with Nicolas. Nicolas, you are head of international development at New Heat. So you are representing a new company, developing great projects and opening up new possibilities of zero carbon heat supply. And in your first presentation, you will highlight the key points of the report prepared by Carbon 4. And you'll come back later to present a real life project. So now, Nicolas, go ahead, the floor is yours.
Thank you, Eloi. Good morning, everybody. I'm happy today to share the 10 key learnings from this Carbon 4 study. So Carbon 4 is a think tank based in France, focused on the alternatives energy for the future. And so the key learnings that I will present here are the executive summary of this study. It's a study where New Heat participated as a financier, but the independence of Carbon 4 was kept. And so these are the views of this report and do not represent our specific view at New Heat. So the first one gives the context about the study. The study was about renewable heat in France in general. And so we realize that heat is about 50% of the whole final energy consumed in Europe. So as you see, most of it is still coming from fossil fuels, and only a little part is coming from renewable energy. We see today that heat is half of the energy consumed, electricity is a quarter, but still the subsidies are sometimes a bit focused on electricity. One of the key aspects of this study was to identify how to decarbonize heat. So of course, the first item is to reduce. So reduce what you consume today and improve energy efficiency. The second one is recovering waste heat. So this is the first two items that need to be assessed. And of course, then you look at what can you do to produce heat from renewable sources. Today, in this renewable sources, 65% is still coming from biomass. Alternative exists like geothermal, thermal, renewable gases like biogas. And of course, if you have certain condition of decarbonated electricity can be used to decarbonize. The objectives in France are 38% of renewable heat in 2030. We are still a bit slow. The speed is not, we are a bit back on our targets. And so I suppose what's happening in France can be also transferred to other countries where the targets have been set pretty high, but where the pace is still not there to decarbonize fast enough. So how do we get on a fast lane? That's one of the questions that we will try to respond today. It's important to see that every heat source can cover different heat demand. So for example, we have heat pumps. They can cover the low temperature grade. So thermal and geothermal are more adapted to low temperature too. And then you have also all the combustion, but that must be prepared, must be kept for higher temperature above 120 degrees. So always assess the merit order. Merit order having multiple aspects. It can be financial, it can be resource, impact on resources, on land, and so on. So the study from CarbonCat gave a good focus on thermal and geothermal, as they can play a significant role for all the temperatures below 120 degrees. There is a high investment cost that has been pointed out by ADEME as one of the key hurdles to overcome, or the key barrier to invest in those technologies. But of course, a few projects are happening with subsidies, and also there are a lot of actors in Europe that can play a significant role pushing thermal and geothermal. District heating is one of the key infrastructure which can benefit from these different renewable heat sources. The picture is a bit heavy, but it's mainly to say you need to adapt the demand. The lower you go on temperature, the more doors you open to renewable heat sources. So typically solar thermal works well up to 100, 120 degrees. If you use flat plate collectors, of course you can go at higher temperatures, but then you have concentrated solar, which can be a bit more stringent on operation and maintenance. But if you can keep, if you want to have no combustion renewable, then keep the temperatures low. You don't need to have steam at 120 degrees to heat up a residential dwelling at 25 degrees. And here you see in New York what can happen with steam networks. Renewable heat is subsidized, and in France, we already have new heat as a few references which have been subsidized by ADEME, the Fonds Chaleur, and by a complement sometimes of C2E specific. But if we compare it to what has happened as a package to avoid inflation on electricity prices since Ukraine was invaded by Russia, we have 24 billion euros which was spent as a tariff shield, and the Fonds Chaleur is yearly only around 370 million, now 500 million. So you can see the scale is not the same to date. I'm looking at this clock because I'm rushing a bit through, but I think I'm still on time. I think it's really important, and that's one of the key focus of the study too, is to make sure that we need to understand the role of each heat source. And of course, it needs to involve engineering companies, that they improve their knowledge of heat pumps, geothermal, solar thermal, the other combustion renewable gases, so that everyone can be used wherever it's most suitable. Solar thermal combined with long-term storage, as you can see here in a project we had studied for an industrial client in Spain, can cover sometimes up to 100% of the renewable energy needs or heat needs for a district heating network if it's below 100 degrees, or it can also cover 100% of an industrial site as long as the process is suitable. The study points out the fact that electrification is also a way to decarbonize heat in Europe. Of course, we need to understand where the electricity is coming from and the impact on the network and on the production capacity. And finally, the study pointed out that today biomass is one of the great vectors to decarbonize heat on the district heating network, namely. But of course, the source of biomass needs to be identified. And of course, when possible, when the temperature is low, other technologies can be used to reduce the use of biomass. In France, the study also focused on the fact that slowly, unfortunately, the forests in France are losing their carbon sink aspect. And so that needs to be very well managed and preserved. That's it from my side. Eloi, I'll give you back the floor.
Thank you very much, Nicolas, for these insights. And I would really encourage the audience to read the report. I think the study highlights very well the need to pay more attention to sources such as geothermal and solar thermal that can support the decarbonization of our buildings, but these are also sources which are fit to meet low temperature industrial demands. So thank you, Nicolas.
Just a final note, Eloi.
Please.
The summary, the executive summary is being translated in English at the moment, and a big work is being undertaken to also translate the study, which unfortunately is still only available in French.
Okay, great.
But should
so
come
at some
soon.
point. Okay, great. This is really good news. So at some point we will share that with our members and participants today. Okay, so thank you again, Nicolas. I'd like now to turn to our next speakers, Hugo and Joël. So Hugo, you are Secretary General at SNCU, which is the association in France representing district heating and cooling. Joël, you are Head of Public Affairs at AMORCE. AMORCE brings together cities in France which are the most active in the energy transition. And this morning you will share with us in a combined presentation the latest data on the French sector and the outlook. Thank you. Please go.
Thank you very much, Eloi. Good morning, everyone. I think I'm going to present you very briefly, FEDENE, because Eloi just did it. So SNCU, as Eloi said, is a French syndicate for public and private DHC operators, which is part of FEDENE, which is a French professional association representing more than 500 energy and environmental service companies. And so today with Joël, we will present you I think the economic and technical situation of DHC in France, which is very particular in the European landscape. And I think I will give Joël the floor to present itself.
Yes, thank you, Hugo. So I work for AMORCE. It's a main network of French local authorities, like you said, Eloi. We represent mainly local authorities in energy transition, and we promote the ecological transition for local authorities in France. And we organize regular events. We gather and regularly publish facts and figures, studies, or reports, and we represent local authorities in national debates too.
Thank you, Joël. So to start the presentation of the technical situation of DHC in France, I think a great way to summarize this situation is to say that French DHC has a very particular place in the European landscape because we cover, the French DHC cover approximately 5% of the heating needs in France, which is, I think, way under the European average market share, which is around 50%, 15%, if I'm correct. However, we have, as you can see on this picture, quite a good renewable and waste heat rate and quite a CO2 content, as we can see on the next slide. Over the past decade, French cities, representing by Joël and French DHC operators, managed to green and to make a great effort to green their energy mix. So we used to say that we double our renewable and waste heat production every decade. And so this greening process relied on three energies. So the first one is waste heat, which is our first renewable and waste heat source, and I think we'll still manage to rely on this source to speed our greening process, as Nicolas said. The second one is biomass. We still have a huge biomass deposit in France, but as Nicolas said, we need to pay attention to the way we're going to use it. However, we will still rely on this on France first renewable sources. The third one is geothermal. So geothermal energy, which is still under 10% of our energy mix. However, recent governmental, public or private initiative shows that all actors in France in the energy landscape wants to in the energy sector wants to develop the geothermal energy. So there is a strong initiatives to develop geothermal energy in France right now. As a result, we reduce nearly by half our CO2 content every 10 years. And so on this picture, we present you two CO2 content, the first one in direct emission, the second one in life cycle analysis. Actually, in France right now, we are going, and in the future, we will only talk about life cycle analysis because we recently changed our building regulation, and it switched from the direct emission to the life cycle analysis. As a result, the DHC operators will need to speed up their decarbonization process, because the new regulation, the new French regulation, doesn't allow carbonized heating systems such as DHC to connect new buildings. So more than 300 DHC systems right now are currently planning to new greening strategy, new decarbonization strategies, and it will all have to be achieved by 2028. So as you can see on this slide, the French DHC managed to always keep on connecting new buildings and to develop itself. So over the past decades, the number of connected buildings increased by 70%, and the network has always been extended. However, what this slide doesn't show is the number of DHC creations, new DHC systems created each year, which is less than 20 new DHC every year, and we need to be way above this number. So we will present you with Joël how we can manage it and the potential after this. However, so we say that the current development of the DHC French DHC system in France was quite good, but it's not enough. The green line on this slide shows you the current growth rate of DHC French DHC systems right now. And as you can see, if we keep on like this, we will not be able to achieve our 2030 objective, which is to deliver 40 terawatt-hour of green and waste heat from our systems. We need to triple this growth rate by the end of the decade. So 3 ways to achieve it, and Nicolas talked about it. First is to speed our greening, to speed and to create more DHC systems all over the country, and we will discuss it with Joël. And the third one is to densify, to connect more buildings, especially in densified in big cities.
Thank you, Hugo. So I'll give you some price details. So as you can see in this slide, renewable and energy guaranteed competitive and more stable prices for customers. Though in blue, you have the average selling price of DH, virtuous and non-virtuous. And as you can see, the green line show that prices for DH who are virtuous is more stable and cheaper than the other DH system. And you can see that the prices only increase of 1 or 2% in 2021. And it's a very good indicator of the stability of the prices to permit to know depend on the variation caused by economic crisis. And as you can see in another slide after that, the prices are more stable, and for customers it's more interesting now to connect to DH than before. So you can pass the second slide. In this slide, you can see the significant contribution of ADEME for the development of DHC in France. And FEDENE is the main system to finance this development. This system was created in 2009, and since its creation, more than 6,000 installations were found by ADEME. In 2000. Sorry, in 2022, the budget of FEDENE increased of 200 million euros, and it's a historic budget for ADEME. It's very good, but as you can see in the other slide and where Hugo said, it's not enough to realize our objectives. So you can see also that the FEDENE is a very good investment for the French government and for France, because we know that €1 provided by ADEME is generated an average of €4 investment in territories. So it's very good investment. And the development of DH repose very strong by this FEDENE. You can pass and as you can see in this slide, what I say before is during the crisis that it's not over enough. The DH are more benefit for customers, because you can see that the variation are more important for DH prices than individual gas and electricity solution. So you can see on this slide the variation without and with tariff shield applied in France. So the green line show DH variation that is more important, very more important than the individual solution. As you can see and you can read, and Hugo said that too. According to Hugo and DH operators, connection requests are massively increased in 2022. And it's a good thing. And the Ukraine crisis and the energy crisis in France, it's relevant for development of DH. It's a very promising debate to energy transition, and ADEME and the government French government applied different programs to help cities to develop new DH and to facilitate the connection for the customers. You can pass, go for the next slide.
Thank you, Joël. Just so with Joël, we represent you the current situation of the DHE market and the heating market. So to summarize it with only one sentence, the current energy crisis and the current Ukrainian war is a game changer in France. So now, how can we address this new situation, and how can we to turn it into how can I say, how can we manage this so this game changer and to speed the energy transition? First, for us is to develop DHE systems all over the country. So we conduct a study with Menergie, Viaseva, which are other actors in the DHE landscape, and we targeted, we located more than as you can see 1,000 DH projects all over the country to deliver more than 50 terawatt-hours of green heat with a great renewable and waste heat rates in 2030. As you can see, we estimate that we need 25 billion in investments, private and public, to achieve this goal. Just to remind you, and Nicolas said it, the Type Shield cost us more than 20 billion in 2022. If I'm not wrong, it will cost us much more in 2023. So we're talking about 25 billion of public and private investments to decrease this spending of public money and to give virtuous systems to cities all over the country. So how can we maintain this virtuous dynamic? So the fact that the number of connection per requests tripled. First, we think we have to address all the markets. So how can we address all the markets? We need to install internal heating water loops in all the residential and tertiary buildings. If I'm not wrong, approximately half of the residential buildings in France doesn't have heating water loops, which means that you cannot collect collective heating systems. I'm not only talking about DHE systems, I'm also talking about virtuous collective systems using solar energy, using heating pumps. So we need to install water loops in those buildings, and we're currently working with the French ministry, with AMORCE, with New Heat and ADEME, which is our environmental agency, to install water loops. The secondary is to address the enormous waste heat deposit we still have in France. Waste heat deposits. We have a deposit above 50 terawatt-hour of industrial waste to energy data centers waste heat. So we need to help actors to collect this waste heat and to re-inject it. And I think Nicolas has a very good ideas and the New Heat have very good ideas to make it true. Third one is to we managed in France to reduce as much as possible the connection costs for residential and tertiary buildings by giving a sort of super bonus to energy efficiency certificates. This bonus will end by 2025. we think we need to extend it to by at least 2030 if it's proven efficient. And we know by the returns, the information we get from our cities and operators that is very successful.
And for the other things, we are agree with Go with that. We already talked about, but it's necessary to double the heat fund. 500 million is an historic budget for heat fund. It's very good, but to maintain the development of DHC and to permit to increase the fund of a new project, it's important to double it to 1 billion by year. It's needed to realize our objectives. And there is also a good program that is started past year. It's called One City, One DH Networks. It's managed by government, ADEME, and different partners like AMORCE and SNCU. It permits to visit. It's like a program of home visits for local authorities and to help them to identify the good projects and to launch in feasibility studies. And this program permits also to fund 90% of feasibility studies for local authorities. And we'll know that 190 cities are already financed feasibility studies by this program, and it's a very good thing. And AMORCE realized 62 home visits to develop a new project, and it's a good start, but it's not enough. And it's important to maintain this program. It's important to develop it because in AMORCE we have 1 or 2% that work for visit local authorities, but it's not enough to help them to develop the 160 1,600 DHC that is needed to realize our objectives.
Thank you very much, Joël. Thank you, Hugo. You provided a lot of very useful information. It's clear that there is the moment for district heating in France, and I think you also made quite clear that there would be need for more support to accelerate the pace of the heat transition. Now, before I open the floor, I will call Nicolas again to put some flesh on the bone, so to say, and present a real case developed by New Heat, a real project in the city of Pons. And Nicolas, I had one question. Sorry, I need to go back to questions. Yeah. Which kind of long-term pit storage are we talking about? So I thought, Nicolas, that when you present the project in Pons, please feel free also to address this question. So please go ahead.
So on long-term storage, you have today 2 type of storage that we can consider in terms of duration. One is really the short-term storage that you would cover, that would cover 2, 3, maybe a week's needs of heat, and typically it's a small steel tank, a few thousand cubic meters, a steel tank, and it's only to adapt demand and production while the thermal heat pumps or other renewable sources are producing, and for example to redistributing it at night or over shady days. And then the picture you had before in the other presentation was presenting long-term storage, and here we're talking about trying to recover all the excess heat produced in summer, for example, from a thermal plant, to re-inject it 6 months later in winter times eventually reheat it with heat pumps, but we still keep 90 or 80% of the heat that was injected. And so there are really these two types. And of course, then there are multiple ways of addressing these two types of storages. And then I'll dive into our case study for Pont. Is that right, Edouard?
Yes, please go.
So we wanted to present a case study which is currently already in operation for almost 2 years now. It's not a big project, but I think it's an interesting project from its innovative point of view and from the model in which it's embedded in the local with the local operator and with the local with the community of cities which was also involved. So where is Pont? Pont is, as you can see, in the Cognac region, and it's a small city of 6,000 inhabitants. And they approached NewHeat as they were currently having a network which was already in operation with a biomass boiler of 2.5 megawatt installed, which was mainly covering the base load. And then on top of that, they had 3 gas boilers to make sure they can use the variability of gas boiler, which is a bit less for biomass because the performance really drops when you reduce the output. So it was already quite a renewable district heating with 73% shares of renewable from biomass, but still 27% of fossil gas that needed to be replaced. The operator is Dalkia. So in France, it's a well-known company which is mainly focusing on managing the district heating and providing heat to the network. So then we were approached by the Monsieur Mouga, which was director of the Comité de Communes, and who wanted to do something about this district heating network. And so the first approach was to say, okay, can we replace the gas boiler by a small biomass unit? And unfortunately, there were a few things we had to cover to validate that or invalidate that option. In the area, wood resources or suitable wood resources were limited. And there was a bit of variability in the costs that we have seen in the last years. And of course, it was in the middle of the city, so they said, maybe we can also reduce the particles or the emissions that we're injecting. And so, especially in a tourist region, they wanted to reduce that in summer. Of course, a second aspect that we wanted to cover is, can we on the network see somewhere waste heat that is not used? Unfortunately, I don't know if you know Pont, there wasn't any big industrial site that could re-inject their waste heat in the network. There's no other sources of waste. Finally, they said, can we use heat pumps to replace the gas boilers? Yes, that was definitely an option that we illustrated. We pointed out that the price would be indexed on electricity price, of course, and that shied them off, and they decided to go for a third solution, and they mentioned solar thermal. I think they had heard about it, but soon came the fact that they didn't really know what it was. They thought it was maybe photovoltaic with some kind of different system. So we had to clarify that. And then we mapped what we could do in terms of specific constraint of the district heating network, of the land availability, in terms of resources locally, what was available in terms of biomethane, alternative renewable sources. And so we came out with a final solution. Just this quick slide to say, this is a common mistake. Solar thermal is just a steel plate absorbing the heat from the sun, but it's not producing any energy or any electricity, sorry, like photovoltaic. It's a different technology, very simple, very low tech, but extremely reliable on the long term. So we compared then the different land grab, so if I may say it, of different technologies. So for 1 gigawatt hour of production, you needed 10.5 hectares of forest in the area. We have a lot of land which is secured for biomass, mainly for construction, but also a bit for energy. And we know we need about 10.5 hectares to produce that gigawatt hour. If we were comparing it with photovoltaic, it was 1.6 hectare to produce energy, so 1 gigawatt hour of energy. And then for thermal, we see it's 4 times more efficient than photovoltaic. So this is an interesting point for district heating, especially when land is an issue in some dense areas. And then this study on the right was done for the district heating network of Narbonne, another district heating network on which we've provided a solar thermal plant. And locally, based on local constraints, they assessed the sources of emission per kilowatt hour produced. As presented previously by Hugo, I think we are about in average 125, if I remember well what you presented, kilogram per megawatt hour. And we see that, of course, gas is a bit higher with a direct emission, which is quite intense. But here we compare life cycle assessments. And so if we take over the life cycle of the asset, gas is quite high. Photovoltaic remains quite high because there's a bit of a lot of materials to be recycled. And then we have biomass and solar thermal, which both have very low grade over the life cycle of the site. We wanted to present a time lapse, but I'll invite you to, when you receive the invitation, to scan this QR code to get it, because we couldn't display it today. Just quickly, what happened in Pont. So here we have the beginning of the construction on the left, and this is at the end of the construction. So we had this little area, which was a public land available for the plant, just next to where historically the biomass, or where now the biomass still is. And here you see, Edouard, you mentioned before, what is a storage tank, thermal storage. Here you see this is the short-term thermal storage that we have installed for Pont. And here at the end of the installation, it's insulated by outside, but it's mainly a steel construction. So what did we do on Pont, and why did I want to present Pont? It's because it's quite an innovative project where solar thermal is using 100%, can cover about almost 100% of the requirement during a few months in summer when the sun is shining. And so the biomass can be completely put on standby. Then in winter season, of course, the production of solar thermal drops a bit, but it can preheat the return pipe from the network. And then the fact that we have a storage allows us also to improve the overall efficiency of the biomass, because it doesn't need to ramp up and down. It can inject excess heat, and this heat can then be used during peak in the morning, because it's a district heating which is very exposed to residential patterns, so high in the morning and high at night. And so it increased, of course, the share of renewable in this district heating network. Why did we want to present this project? Because it's quite innovative in terms of solar thermal. It was the first plant using trackers, which allowed them to focus on the sun, but it also has the benefit of being easy to operate. So in case we have excess heat, our storage is full, and the district heating cannot use the heat, we can off-track our solar thermal panels. It's like a on-off button, and we can so operate it more finely. Then, of course, to balance production and demand, we have a heat storage, which can be injected, as you saw, at multiple stages in the heat production cycle. The importance is that it's kept out of oxygen to avoid rust and corrosion, and to make sure that it can be operated for 25 years. And of course, we need to keep a good stratification in the storage, so that we can keep high temperature at the top, lower temperature at the bottom. And by increasing this delta T, we have a larger storage capacity. And this is the little, it's just a distribution hub, or the solar skid as we call it, where we have the pump, the heat exchanger, nitrogen preparation, and all the automation and controls. So this is the supervision that we have. We won't go too much in detail, but it's important to say that all our plants are operated remotely from Bordeaux, and then we'll work locally with operators which can have an intervention if something is required. One interesting aspect of this project is also how it was structured. The business model around it made that it was New Heat is a sole investor, not a sole investor, but is the owner of the assets, and has created a SPV, which is a project company dedicated to operating this plant. So solar thermal, storage, heat, and the pumps for distribution for 25 years. We had the finance was done by New Heat, partially by financial institution, and finally 3 regional funds helped took a minority stake in the SPV to push this transition to a greener district heating network. The SPV is an autonomous company, so it can be profitable for 25 years. Yeah, and so that's a key structure which was designed around that. And so New Heat is the long-term operator of this plant, providing heat to the other operator, which is Dalkia. So we have a bit of background of this plant because it's operating now. And so we know how it really works. It's always interesting to have the modelization and to see that we were quite close to what actually is delivered to site. We have a good production over summer. As you can see, we cover almost 100% in June, July, August, and then in winter we drop back and leave the biomass working full speed. But then, of course, the biomass can also use the thermal storage, as we said before. And so 200 tons per annum, it's a small project, but still it's quite an interesting case study to present. And finally, what were the economic results? So for a capex of 1.3 million euro, which was covered by 60% subsidies. So we are really grateful that the system in place in France allowed for a great support of this technology and made solar thermal economically viable here against other fossil fuels. The thing is they have a solar heat price which is stable over 25 years. It was a price that was competitive for the network and brought down the price level for the end user. Finally, the practical feedbacks that I would like to point out is first a good collaboration upfront with the district heating network is necessary to plan reduction in temperature when it's available and to make sure that solar thermal can be used. The summer demand is always quite a difficult one because if it's over estimated, then of course we have overproduction in summer, and that, well, the investment doesn't benefit from that if we have to waste heat and use energy to remove heat. And of course, the link between the city, the operator, and us, New Heat, as a solar thermal plant operator is key and is the only way a long-term partnership can happen. That's it from me on this specific case study.
Thank you, Nicolas. I think it was really brilliant. Nicolas, I have one question to you. How do we make sure that we have many more projects like in Pont. I mean, your view as a project developer. So is financing the bottleneck? Are there technical or organizational barriers? Do we need more systematic coordination of actors at local level, more heat planning? What do you need?
I think it's important to have a overall knowledge of renewable heat, which is expanded through engineering companies, through operators, through cities, which are also the planners of the cities, to make sure that thermal heat pumps, biogas, biomass are always assessed and compared with their merit order for each technology. So I would say there's a technical aspect which is linked to the engineering knowledge around this solution. Then, of course, one item that we mentioned before is if you can lower the temperatures in the network, then you open doors for more technologies. Of course, if you go above 100 degrees, then biomass and gas seems to be the great candidates. But if you can lower the temperature to only the required temperature, then you open the door for quite efficient heat pumps, solar thermal, and geothermal technologies. And finally, you mentioned subsidies. Of course, they're great, but today we are supported. We need to make sure that each time there is a renewable energy directive from Europe or from countries, that waste heat is also mentioned. Sometimes we're excluded for some because renewable energy is focusing on electricity. And I think that's the main barriers that we see. And if knowledge is there, if the subsidies are there, and if the networks are lower temperatures, then I think the future is green for green energy.
Thank you, Nicolas. There is a question. I think it's one for Joël. It was mentioned that in your slide, that we would need incentives for installing secondary thermal loops. Could you develop a bit this point? And are you of the opinion that in France and maybe on some other relevant markets, I mean, regulations should ensure that all new buildings in urban areas have a thermal loop so that they can be connected at some point to district heating? Can you elaborate a bit on this? I think it was an interesting point.
Yes, thank you, Eloi. So yes, it was a request, an AMORCE request for now to apply this obligation for new buildings. And it's very important because in France, many buildings and the principal buildings are not disposing that thermal loop, and it's a problem to connect to DH later because it's more expensive to connect and to convert buildings to connect him to district heating without this thermal loop, and you go have probably some prices indicator, but I let him complete if it's necessary. So I'm also request that that for the future we took place this obligation for new buildings and to facilitate the connection at a later stage. So it's connected with the mandatory connection that exists in France in cities with DH. So in France, we have a mandatory connection. The local authorities have the possibility to apply that when there are DH that exists already. But in DH and urban area, without DH, there is not obligation to have this thermal loop, and we think that it's a good solution to promote collective heating solution that is good for energy transition and to permit the potential connection for at a later stage.
Thank you very much, Joël, because I've already heard about this problem or the cost of connecting actually buildings without thermal loop. Of course, it's an issue. Thank you. I have one, actually, there are many questions. I will not address all of them, but there is one for, I think it's for Hugo. Hugo, you mentioned the need for de-risking mechanism for waste heat projects. So in France, but also across Europe, I mean, we all know there is a gap between the potential for waste heat and its actual use. It's sort of well documented in the reuse heat project. Could you develop here what are the asks of the sector to get all these projects with waste heat off the ground?
So so if we focus on the valorization, so the reuse of industrial waste heat, what we noticed that it's very difficult for an industrial actor and a DHC operator in the city to agree on the length, the way to valorize the waste heat, because a DHC, a city will need long-term contracts, steady contracts, when while the industrial actor will need short contract, which can be reconducted, extended from time to time. So we asked the ADEME and the French ministry to launch a working group. So we are currently working with them to first assess the situation and to propose a solution to how can I say, to de-risk and to make it much more easier for the industrial actor to sell its waste heat. I don't know if it's the answer you were looking for, Edouard.
Yes, I think it was very useful. Thank you, Hugo. Now there is another question I would like to ask you. Let me go back to the chat, because we are professionals, but we are also all citizens. I think this is a question for Joël and Hugo. So I'll read the question. Sorry, it has disappeared from my screen. Voila. If I live on a street that is close to a district heating and cooling network, but not yet part of the network, how can I get connected? Do I need to ask the district heating operator? Do I need to convince all my neighbors first? What are the chances that the operator will make the extension?
I don't know if Joël, you want to take the floor on this one, and I will complete.
Yes.
Very practical one.
Yes, if you live in the street and in the collective building, you are first, you're in France, you have to convince your neighbors, because in France we have a regulation to manage collective buildings with syndicates. So you have to convince neighbors. And you have to ask to DH operator and local authorities that is the owner of the DH to have the connection. But if the DH is in the street, maybe you can complete, but the extension is not very complicated, and the operator often accord this possibility when the neighbors and the buildings are okay to connect to DH. And as you said, Hugo, there is actually a program to fund this connection, and the cost is very low actually. And with the Ukrainian crisis, you make economy for the long term too by this connection. And there is the other situation that if you are in an area of a mandatory connection and the buildings are changing its heating system, then in this case you have an obligation to make that demand for the operator and for the recruitment. So it's a little bit different when you are in area with mandatory connection is in place.
Thank you very much for these elements, and I can see that the time is flying. There are other questions, but what we will do is that so this is for participants. I mean, we will forward your questions to the panelists. Okay, I think it was well really useful to focus on development in France, and I think there are best practices that could obviously be replicated on other markets. Well, I think of the use of investment aid, which is a very strong means to develop sustainable heating infrastructure. And the heat fund or Fonds Chaleur managed by ADEME has obviously been instrumental in boosting new projects using sustainable biomass, geothermal, solar thermal, and waste heat. Of course, such a measure should be combined with ways to manage risk and ensure the heat load for operators. Then there is a big role for local governments to play in engaging all local actors to develop green heating. So this is the role of heat planning. We also heard that more needs to be done in France, and I think this also applies to other markets across Europe. The Fit for 55 package that is being negotiated right now between the Council and Parliament should, in principle, lead to more support for green heating. This being said, no need to wait for the finalization of negotiations on the package and its implementation. The current energy crisis shows that we need more focus on green heating now. I'd like to thank our speakers once again. I would also like to thank our participants. Thank you for your trust. And a little commercial, we will have our Torino, our Congress in Torino. So this is the global event for the district heating and cooling community. So we are expecting over 350 participants, many sessions, a lot of great speakers. So please come to Italy and continue the discussion with us. So once again, thank you and have a great day. Bye.